Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about alcohols, phenols, ethers and epoxides. CC6 Unit 2 Lecture 6. So this will be highly useful for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about ethers and epoxides. So basically preparation and reactions with acids, reactions of epoxides with alcohols, ammonia derivatives and lithium aluminum hydride. So this is the general formula of alcohol that we know, ROH. So now if we simply replace this hydrogen with a R group, so that becomes ROR. So this is the general formula of ether. So if both the R's are equal, then that is called symmetrical ether. If R and R group are not equal, then that is called unsymmetrical or mixed ether. So for example, when R equal to CH3 and CH3 both the sides, so this is called methyl ether or methoxymethane. Similarly, R is C2H5 both the sides. So C2H5 O C2H5, that is called diethyl ether or ethoxyethane. Similarly, if one side is C6H5 and another side is methyl, so that is called C6H5OCH3 anisole or methoxybenzene. Similarly, one side C6H5 and the other side C2H5, so that is called phenol or ethyl phenyl ether. So now we talk about preparation of ethers. So first we can prepare the ethers from dehydration of alcohols. So if we take two equivalent of alcohol and if we react with H2SO4 and heat it, we get ether plus water. So here we can see, so two equivalent of C2H5OH. So if we react with H2SO4 and 140 degrees Celsius at, so we get diethyl ether. Similarly, the ethanol can undergo dehydration to give rise to olefin. So this is the limitation. The next is Williamson synthesis of ether. So the reaction of an alkoxide or phenoxide ion with an alkyl halide. So C2H5O minus Na plus can react with alkyl halide CH3Br. So you can get the ether C2H5OCH3. Similarly, C6H5O minus Na plus can react with ethyl bromide CH3CH2Br. So we can get C6H5O CH2CH3. So limitation. So aryl or vinyl halides cannot be used because of low reactivity towards nucleophilic substitution reactions. Then reactions of ethers with acids. So ethers are relatively inert in their chemical behavior and are unaffected by alkalis, oxidizing and reducing agents. So ethers are basic in nature. They form oxonium salts with strong acids. So you can see this is the ether. So ether has a lone pair, oxygen has lone pair of electron. So that can act as nucleophile. It can attack to H plus as a H plus is the electrophile. So you can have this dimethyl oxonium chloride. Similarly, diethyl ether can react with H2SO4. You can have a diethyl oxonium hydrogen sulfate. So these salts are stable at low temperature and are in a strongly acidic medium. They are decomposed by water to give back ether and the acid. The next is epoxides. So this is the three-membered compound with one oxygen atom. So cyclic ether. So it is ethereal oxygen is the part of the ring. So that is three-membered ring. This is called ethylene oxide or we can call it simply epoxide. Similarly, five-membered ring with a oxygen as part of the ring, that is called THF, tetrahydrofuran. Now question arises how to prepare the epoxide. So we can prepare the epoxide by using porbenzoic acid. So we can react alkene with porbenzoic acid. So we can get epoxide plus benzoic acid. Similarly from halohydrines. So it can react with a base OH minus 7. So it will take this proton. So this becomes O minus, and O minus can attack this CH2 and it will kick out Cl as Cl minus. So we can get this epoxide. And reactions of epoxides. So these epoxides can react with acid. So it can give rise to ethylene glycol. Similarly, this ethylene glycol can react with another equivalent of ethylene oxide and acid. So it will give you diethylene glycol. Similarly, ethylene oxide, the oxygen lone pair can attack to H plus. So you can have this protonated ethylene oxide. Then the base oxygen lone pair of ethanol can attack this CH2 and this CO bond will break on this OH plus. So we can have this 2-ethoxy ethanol. Similarly, the epoxide can react with ammonia and the ammonia derivatives to give rise to corresponding amino and hydroxy compounds. So NH2, CH2, CH2OH. The next is cleavage of ethers with acids. So we can have HI hydroiodic acid. So we can have phenol and methyl iodide. So this oxygen lone pair can act as nucleophile. It can attack to H, hydrogen as H plus, and this HI bond will break on I. So that becomes I minus. So we have this oxonium ion. So now I minus can again act as a nucleophile. So it will attack to methyl and this O CH3 bond will break on O plus. So we can have this phenol and methyl iodide. So as you can observe, the C6H5 plus phenyl cation does not form in SN1 reactions. So HI is a stronger acid and I minus is a better nucleophile. The next is a reaction of epoxide with lithium aluminum hydride. So this is the structure of lithium aluminum hydride. So it is a hydride donor. So here H minus attack to the less hindered side of a epoxide and this bond will break on oxygen. So as a result you get this oxo anion and this upon protonation you can have this alcohol as the major product. So basically the lithium aluminum hydride, the hydride H minus will attack the less sterically hindered position of the epoxide. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. So this is for class 11th and 12th students, Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.